going to go over 1.5, multi-step equations. And we're going to do 1.6. Axioms, inequality, and the real number line. One point seven. Comparing pairs of numbers. When solving a multi-step equation, I'm sure all of you have heard different versions of rules on how to do that. But basically what I always taught was you had 3 steps. One, you simplify each side of the equation. 2, get the variable terms you're solving for on one side and everything else on the other side of the equation. Find out what 1 and x is equal to. Make whatever is in front the x into a 1. While you're doing all of this, what do? We keep the equation what? Balanced. Okay? While doing all of that, you need to keep the equation balanced. First step, simplify. Second step, get your variable terms on one side, everything else a number, a variable equal to number. Third step, find what 1x is equal to. If you follow those, you'll be fine. Example, 3x plus 4 is equal to negative 3x minus 20. For those of you that have always had problems with this, my suggestion to you, I used to tell people to circle the variable term you're solving for. And remember that things over here cannot be added to things over here. Okay, this is one side of the equation, it's completely separate from the other side. First of all, is there any simplifying to do here? Everybody watch, and then I'll let you write it down. Is there any simplifying to do here on this side? Can I add 3x to 4? How about negative 3x to negative 20? Okay, first thing to do, guys, you'll see this. 3x and negative 3x don't think they add to 0. They don't necessarily do. When you have basically the same type of thing on each side, it doesn't matter where you start. You want to get rid of this, or do you want to get rid of that? One on the right or the one on the left? Which one? Right? So, how do I need to make this into a 0 because all I want left over here is a negative 20. What do I add to 3x that makes it into 0? Add a positive 3x. If I add 3x on this side, though, I have to what? Add 3x on the other side. The reason I put it under here is because they're like terms, aren't they? So what I'm left with on the left side is 6x plus 4 is equal to a negative 20. What is my next step? There's my variable term I'm solving for. I still don't have variable term on one side, everything else on the other, do I? What needs to not be there? The 6x, the 4, or the negative 20? Which one? What do? I add the opposite. Add a what? Because that makes it 0. What allows me to do that? If I add a what? Huh? Negative 4 to the other side. Remember, adding a negative 4 is the same thing as subtracting 4, isn't it? What am I left with over here on the left side now? That adds to 0, leaving 6x plus 0 is just a plain old what? Equal to, what is negative 20 plus a negative 4? Negative 24. Have I got my variable terms on one side, everything else on the other? What's my next step? Divide by, make whatever's in front of the x into a what? If I have a fraction in front of there, multiply by the reciprocal. If I don't, just divide by itself. What is itself? 6, not 6x. If I divide the left side by 6x, what do I do to the right side? Divide it by 6. What am I left with? This divides into 1. X is equal to what? What is negative 24 divided by positive 6? Negative 8. Write that down.
Negative 24 divided by 6.
It's not 8, is it? What in the world am I thinking? Negative 4. Wow. Sorry. Must have been thinking 48 in my head, huh? Doesn't look like they have any that you have to simplify, so we're going to move on to section 6 if you guys are done writing that down. Okay. 1-6. Solving an inequality is the same thing as solving an equation except for two key things. The solution is the entire inequality. Example, if I said x is greater than 3, if I say x is equal to 3, what's the answer? 3, right? Think about it though. Is the answer 3 here? No, the answer is say this. Instead of saying x, say all the numbers greater than what? That's the answer. So any number you can think of that's what? Bigger than 3 is a solution. Make sense? See how that's different than saying x is equal to 3? 3 is the actual answer, isn't it? Here, 3 actually isn't an answer, isn't it? It's the solution is the number's what? Bigger than 3. Okay? Second thing, and this is the thing that you got to remember. When you multiply or divide both sides by a negative number, you have to what? Anybody remember? Flip the inequality sign. Look, my hand's still there. Sometimes saying something corny gets everybody to wake up on a Tuesday after. I was proud of you guys for catching my mistake. Of course, I did that on purpose to make sure you guys were awake on Tuesday after a 3-day weekend. That's the whole reason I did that. Yeah. All of this is review, so I'm hoping that I don't have to go into it too much. Okay? So we're going to do an example, and then what we're going to do in the example, after we're done, we're going to graph our example on a number line. You guys remember what a number line is, don't you?
This starts off with 0 in the middle.
Basically, it's the x coordinate. Remember x-y axis?
Yeah.
A number line's just the x, no y. It's just left and right.
Like,
Yeah,
it usually starts with 0 in the middle.
exactly. Everybody got that? We good to go?
Yeah.
Okay, so let's do an example. How about something nice and fun? How about 4 minus 3x is greater than or equal to, we're going to do 2 examples. Is greater than or equal to negative 5. That's example 1. Example 2, 2x plus 4 is greater than 8. So we're going to solve and graph on the number line. Later on in the chapter, we'll graph that on an XY coordinate plane. We're going to solve and graph those two on a number line. How about we do the one on the left in red? Like I said, solving this is the exact same as solving an equation. You just have to remember that your answer is the whole inequality. You know, remember, the answer in an inequality is never going to be 5. You see what I mean? It's always going to be numbers bigger than 5, smaller than 5, 5 and the numbers bigger, things like that. And the other thing is, but the big thing is, when the actual process of solving it, anytime you divide or multiply by a negative number, light bulb ought to pop up. Oh yeah, I got to do something there, right? Now, what would my first, there's the variable term I'm solving for, right? The equal sign separated from one side to the other. Well, the inequality sign does the same thing. I want to get that negative 3x by itself. What's there that I don't want there? 4. It's simplified, so I don't want that to be here, so I'm going to add the opposite. So I get 0. What's the opposite of 4? Huh? Negative 4. Wake up. If I add a negative 4 over here, what do I have to add over here? So I'm left with negative 9 over here. So what I'm left with is negative 3x is greater than or equal to negative 9. Now wait a second. I just did something negative to both sides of the equation, didn't I? However, what's the rule? If I what? Multiply or divide both sides by a negative number, I flip the sign. Did I multiply or divide here? No. Come in. I added a negative number to both sides. Okay, that's not multiplying or dividing. Raven, don't forget to, let me get this to you when we're done with those. Okay? So, with that in mind, I don't need to flip it yet, do I? Okay, next step. I've got my variable term one side, everything else the other. I don't want to know what negative 3x's are greater than or equal to. I want to make this negative 3 into a 1, basically, don't I? Everyone agree with that? How do I do that? Divide by what? Itself, whatever's in front of the x. What is in front of the x? Negative 3. So what do I divide by? Negative 3. If I divide the left side by negative 3, I got to divide the what? What should pop up right now? What did I do? I multiplied both sides by a what? By a negative number. What happens to this sign? Instead of being greater than or equal to, it becomes what? Or equal to. Because of that right there. Because I divided both sides by a negative number. What is a negative divided by a negative? 9 divided by 3. That's all you got to do to make a number line. You ought to be able to make one that neat. Okay? To graph this, what am I going to do? Where am I going to start? That's the thing that sometimes messes with some people. Starting point is the key. The number on the other side is your starting point. What you have to ask yourself is, am I including that number or am I not including that number in my solution? I'm talking about and say this, it makes more sense when you say the numbers instead of x, right? The numbers less than or equal to 3. Am I including 3 in that statement? Huh? I am. So what you do is you put a circle around 3, and since I am including 3, I do what? I shade it in. Now, I'm talking about the x is less than. Which way do the numbers get less than? To the left or to the right? Huh? To the left. So I shade, I have 2 colors, so it's easier to see my shade. For those of you that don't, you probably need to shade it a little thicker. Now, do the numbers start there, stop there at negative 4? Huh? Are there more numbers less than negative 4? So we have to denote somehow that we mean so on and so on forever and ever. How we do that, put your phone up, is by coloring in the arrow very well to indicate what you're talking about. It's all about communication. Would there be any, on something like that, even if that was in the same color, would you know which numbers I was talking about if I looked at that number line? It's pretty obvious, isn't it? Okay? I expect you to do the same with your homework. Does it have to be a work of art? No. I mean, look, mine's crooked. My arrow's a little crooked, but you know what I'm talking about, don't you? That's the key. Okay? I've labeled this down here, all that stuff. That's what you guys need to realize. You're right, there's a lot of different ways to write things down, but do I understand what you're saying? Communicate. Can I tell for sure that you did the work? Well, show these steps. I want to know that you understand how to do it this way. All right, over here to this one. What's my first step? I'd add a negative 4 here to make that 0, because that would just leave 2x over here, would it not? Well, what allows me to do that? If I add a negative 4 over here, I have to what? Add a negative 4 over here. What's the result here? 4. I didn't multiply or divide both sides by a negative number, did I? Huh? So that doesn't change. So it's 2x is greater than what? 4. I don't want to know what 2 of these x's are equal to. I want to know what one of them are greater than or less than. What of them are. So what do I make that 2 into? Come in! A 1, correct?
Yes.
So what number do I divide by 2 to make it into a 1? If I divide the left side by 2, what do I do to the right side?
By 2.
Did I divide both sides by a negative number? Huh? No. So do I do anything with that sign? Stays the same. X is greater than, what is 4 divided by 2? Huh?
2.
2. Draw my number line. Where do I start? Where do I start here?
Start on 2.
I start on 2. So I circle positive 2. The question is, am I including the number 2? I'm talking about the numbers greater than 2. So if I said, you got to give me more than $2, would giving me $2 be sufficient? No, that's what this is saying. It's got to be more than $2. So are you including 2? You are not, so what do? You make it obvious that you're leaving that what? Empty. Obvious, I colored it in here, right? Obvious and empty. Talking about the numbers greater than 2. So is that the numbers to the right or the numbers to the left? So I color in. And to denote that I'm talking about so on and so on, what do I do with this arrow? Make sure it's nice and it's bigger and easy to understand. I think you know what I'm talking about there, don't you?
Yes.
Kristen? You bring your stuff. Any questions there?
No.
1-7 is a little bit different. We need to draw a nice big XY coordinate plane. Yes. Now, what we're going to do to compare numbers is we're going to compare them to this graph, y is equal to x. Okay? Quit writing notes, please. Just why don't you grab that, throw it away. And when we do that, you got to remember that in an ordered pair, it's always in the form. What are ordered pairs always in the form of? X comma what? Y. Does everybody understand that?
Yeah.
So, the y equal to x line would be 1 comma 1, 2 comma what? 3 comma 3, so on and so on, right? And if you want a prettier picture of this, you can look in the book. This is the graph of everywhere where y is equal to x. Now, for your first part of your assignment, they're going to ask you, tell which statement is true. A is greater than B. I'm sorry. It says A is less than B, A is equal to B, or is A greater than B? They're going to ask you to answer those questions, and what they're talking about is some ordered pair, A comma B. Now, everybody don't worry about writing this down, just listen. Do our first example. Which one does this satisfy? Is A less than B? Is 8 less than 4? See, people might have problems with this. You're like, is it really that easy? Yes, it is. Is 8 equal to 4? Is 8 greater than 4? So the answer is what? It satisfies that one. A is greater than B. Make sense? Next one. Which one's true here? Is A less than B? Think.
Yes.
Yes, it is. Why? Because a negative 10 is a smaller number than a what? Positive 1. So it's A is what? Less than B. Is your answer. That's what's true. Make sense? Then they're going to draw you a picture, and then they're going to give you things on a graph and say whether they're on the line or what have you. Make sense?